Hello, ladies and gentlemen, and welcome. Hey, Arcane, 2 streams in 2 consequent days. You're spoiling us. I know, it's a crazy world. Consecutive days is probably what you meant, but I get your point. Yeah, the thing is that I got a little bit annoyed at yesterday's stream. Oh, and OBS has once again lowered my volume. So as I'm talking now, this very sentence, I'm clicking up the decibel of my microphone. Please let me know if this is too much. Just like last time, I need to actually sort of write down these decibel levels for myself because OBS keeps reasoning them. Like, why does OBS advanced audio settings not store these things? It's very strange. Non-English speaker, sorry. Yeah, well, likewise. Or well, I guess we both are English speakers because we speak English, but it's like not natively. Right, so desktop audio is like 0.3 decibels. And then mic is like 3.0. Is that right? Let's go with that for a bit, and as always, let me know if the levels are just borked. Regardless, welcome everyone, or I should say perhaps welcome back, because it's less than 24 hours since I streamed last time. And I'd like to tell you a little bit of a story about my internet connection. Let's make sure we can get the build to run. Actually, I didn't build it there. I did a little bit of cleanup since yesterday. A very angry cleanup session last night with no working internet at all. And we are basically resuming what we did exactly yesterday. Today's sound level is better than yesterday. Okay, well, I might have bumped it even slightly more than I did. Oh, here's a bug, by the way. If a terrain is completely flat, and so the PhysX height field is completely flat, for some reason the raycast doesn't hit it. Like if I make a bump somewhere on this level, you can no longer put the camera beneath the terrain, and that seems to be a bug in PhysX. Let's verify my claim here. Truck bed work was the one that we were looking at. So I'm just gonna bump like this corner here, like far away from, like just a little bit, like that. Just about see that there's a bump there. And now let's play this thing. Yes. Oh, actually, it still doesn't hit it. It's interesting. Let's make a bump here closer to the car then. I thought it was just like, yeah, now we can see. But it still kind of goes through. That's interesting. Anyway, this is based on like raycast on the physics side, so it kind of does work. If you make it even slightly more bumpy around the car, I bet it's really difficult to actually get it to hit. Yeah. No. Maybe not. Maybe it's actually a bug in my code. Who knows? Who knows? Anyway, that's neither here nor there. So yesterday we had a pretty good stream. The SDF collisions didn't really work out because of another issue with PhysX, which is the fact that height fields and dry meshes don't collide. They don't generate collision pairs, apparently. Or then I'm doing something wrong. But it kind of looks like that is the case. And so I kind of ditched the idea of using SDF collisions for the bed, for the truck bed. For now, at least, we can quite easily swap that out for a collision for this. But that was the idea, because this is a concave object. That was the idea, to just like have it drive it with a concave SDF object. That didn't work out. Anyway, at some point during the stream yesterday, the connection was lost, and luckily I was able to switch. I have a sort of a backup internet connection, as a matter of fact. It's kind of a backup these days. I'm contemplating whether or not I should shut it down, but based on yesterday's experience, I might need it, so maybe I won't do that. But we live in an area where we can't quite get fiber yet, at least not without paying through our noses. So I recently upgraded to a 5G connection, and it's been working pretty well. Except yesterday it just completely broke down, and I wasn't able to get any connection at all. And let's go to maybe depot. So I had some family business to take care of. When I came back, I realized that it's actually still not connected, and I can't get any connection at all. It's just completely dead. But of course, it was so late that I couldn't get any hold of anyone on the sort of consumer side for the operator. So today I call and go like, hey, what the hell is going on? Like, I can't get a signal anymore, and it was working pretty well for a couple of weeks. Turns out they had switched the SIM card number on their side. Just suddenly switched it to another SIM card, probably as a mix-up of like activating someone else's connection or something. And that's why it didn't work, because it was registering another SIM card than the one I had physically installed in my modem. So that's why yesterday's thing didn't work. It's the most stupid thing ever, but can't be helped. So hopefully that was like a once in a lifetime experience, and they won't be disabling my internet connection again anytime soon. But if that happens, I'm just gonna flip a few Ethernet cables, and then we'll have the backup one. Looking into Starlink. No, not really, to be honest. I'm holding out for when the city does some renovations on our road. At that point, they will basically almost by law have to like put the cables, the power cables and everything underneath the road, and when that happens, then they will put fiber as well. We have fiber. I think I've told this before. This story. We have fibers like maybe like 3 or 4 neighbors away from us have fiber. So it's just like a very very tricky and pretty expensive part to dig to get it all the way to our house. Yeah, as part of the cleanup that I did yesterday, I actually just went ahead and made these concave objects out of primitive objects, just like we normally have. Now we can see that they are indeed colliding correctly, and they're colliding with the ground and everything. So we are quite simply just gonna have to use this, I think, for now at least. Luckily, it's not super tricky to like compose these kinds of objects out of several convex meshes, but it's a little sad that it doesn't work better than it does. Anyway, so because of all of that, I was like, that was annoying. It was such an anticlimactic end to the stream and everything, that I just wanted to continue where we essentially left off yesterday and continue working on the truck bed logic for for the truck. Yeah, that is what happens when you drive on something that's not set as drivable. Super wonky and weird. And just kind of slide away, slide all over the surface. But yes, we did a little bit of stuff yesterday. And basically, if we drive here to this depot, we should have the truck there doing its sine wave truck bed thing. And today's goal would be to essentially have a tiltable truck bed, which also has physics associated with it. And it will be networked and it will be, you know, synchronized and all of that. So this thing now just sort of wiggles it back and forth like this. And it kind of looks like it might actually, you know, be controllable or whatever. But of course, if we just put a box here, actually we need to put it like maybe over there. We can see that it doesn't actually have any physics. So it's still just standing on side of the truck itself. Nikita says, hi, you have a wonderful project. I've been watching you for a long time and inspired by your ideas. Thank you. Well, you're quite welcome, and thank you for the kind words. And hopefully I'll get a new version of this into your hands pretty soon. But thank you. That I'm happy to inspire. Right, so where were we yesterday when all of the things went down? So I added these collision shapes, and actually I even found the hatch. It was just me being bad at my job again yesterday. So I was wondering, like, okay, here's the bed. Here's the bed. That's good. There's a truck. Where's the hatch? Well, the hatch was actually just nested here underneath this thing all along, because it needs to be parented underneath the bed, of course, so that when you tilt the bed backwards, the hatch also tilts, and then you can rotate this, you know, open it like this, bloop, something like that, and then of course we'd have like another one there on the other side. That was the idea. I haven't done like a whole lot of parenting actually in Blender, like ever, which is why I just didn't figure to actually look there in the scene collection for that. But that means that we have a little bit of a scene graph going, transform hierarchy of these things, right? Because this bed is nested under the car. The car moves around, and it is nested, and it can do this kind of movement. And then we have these hatches here that is nested underneath the bed, and they open sort of horizontally like this. So we have a 2-level graph going, and I was thinking we would actually just like sort of use the same sort of code that I did for the crane arm. And I think that might be the easiest way to go about getting this to work. So we're going to take a little bit of code from the crane arm. We already looked at some of it yesterday. So we have it here. I actually have yeah, I did a little refactoring here. This is actually pretty old stuff. This is about a year-old code. So graph nodes, the graph here on the crane arm side is more complicated. It has a root, an offset, 2 bones, and then an arm end, and like each one is nested underneath the one above it. We won't have that many, but we'll have sort of like a similar system. And the way I've done this is an enum, and we have a graph size. That's basically like the number of elements in the enum. Then we have a graph, which is quite simply just a scene node pointer array. And this kind of strange looking syntax here is how we can initialize. I'll need to look this up every time I do this, because it's a little convoluted perhaps. So graph, it is a scene node pointer array, and we initialize it to C node pointer null, and we do it graph size times. So this is sort of like statically initialize all of the elements in this array with this null value. And we can even do you can do that in Zig these days, so that's neat. Right, and that essentially gives us a graph. We still need to create the graph somehow. And I think there is a create graph function. There is, yes. And I briefly mentioned this yesterday, that we do it a little bit differently on the server versus on the client. Because on the client we want to use interpolation. So if we go, actually just take that away for a second and we go directly to, actually we can do it in the truck bed work, that's probably fine. So if we look here at the, we have the physics shapes there, and you can see that they're sort of jittering a little bit, while the visuals are smooth. That's just because the physics are running at a fixed 60 frames per second, while the visuals are interpolated. And here we're running at 75. That's just because my monitor's refresh rate is 75. But that essentially means that you want to nest your visual things, so like the truck bed, for example, under the scene node that is interpolated itself. And we can get that on the client. The graphics engine gives us a scene node that is interpolated. And then you can just nest things underneath that. And of course, if you just like nest something under that and then you don't move it, then it also gets interpolated because it moves around with the parent and all of that, right? But here on the server, now that's a server, we don't have that. We don't have anything to attach it to. So we actually just create a new node, and that is the root of the hierarchy. So server only parent node. And then we set the graph parent to be that. On the client side, we can just do like get render scene node. That's the interpolated one. And then we use that as the graph parent. So yeah, after that, it's just exactly the same. First we create the root, create child node of the graph parent. Then we do the offset node is like, give me the root node and create child node out of that. You know, then you can set positions and orientations, and they are set in the parent space. So that should be pretty good. We can do the same thing with the truck bed, and then if we later on want to do something more exotic, then you know we have this sort of mental model to work with, not even just a mental model, but an actual model to work with. The joints are a little more complicated. We need to have a few of these physics parts. We have arm physics part as an actor joint and an inverse joint actor A transform, which sounds kind of complicated. Again, here we can use just dot null. So that is just, we store this when we create the joint. So let's see here. The arm bones, they are essentially just like the two pieces of the mother vehicle's crane that we move around. Might be a little difficult to see them here actually. Oh, and I think they're actually only, yeah, okay, they're only visible on the client. Oh, sorry, on the server. And here we have some of this mass frame stuff. Really what we essentially want to look at is these, or are these magenta colored boxes. So this is one bone, and this is another bone. And the masses just sort of protrude from that, but they're not actually like collision volumes or anything, these black ones. And so, if we move this around, we have essentially, we have the root somewhere there, and then we have the offset, which is this thing that just like rotates around with this big round thing here. Then we have one bone here, we have another bone there. And I think the visuals are actually completely detached from the arm. So let's see, we create bone 0, shape transform. Blah, 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 blah. Okay, right, so first of all, we get from the graph, we get the bone 0 to vehicle local matrix. So in the local space of the vehicle, where is this bone supposed to be, positioned? And then we also get a bone to world matrix. And that is where we actually create, because rigid bodies are created in world space. Then we create the actor here. Before that, we create a shape. We will also need to do this create box thing with those blueprint property things that we added yesterday. So that's fine. And then we do some bookkeeping stuff here. We add the actor to the scene, and then we store this inverse joint actor a transform thing. And that is essentially like this matrix that we calculated where in the space of the vehicle that we want to create the object, the bone, or the rigid body, the actor, whatever you want to call it. We take the inverse of that, and then we create it in the local space of the vehicle. Then later on, we can use it here. This is in the update, apply steering values, which is called from the update. This is where we move around the thing. And let's have a look here. So we can just move the scene nodes in the graph like this. And then if we have a joint, then we essentially drive the joint by setting drive goal pose. And that causes PhysX to move the joint to, where we actually want it to be. Now the visuals, so the things that are executed on the client, they can just follow these scene nodes. And since we've attached the whole graph to an interpolated node on the client, the whole thing will be interpolated. Not the individual movements that we do to the individual parts, but as far as the whole vehicle moving around and not the jittering. The bed or whatever we attach to that will also move around and sort of behave nicely. So this is essentially like the update code for both the visuals and the physics. But this handles the visuals on the client, and then if we have physics parts, this handles the physics in a non-interpolated fashion on the server. So I think that should be essentially exactly what we want for the truck bed as well. And this drive goal pose with suitable parameters for the joint should make it so that we can lift it up. We can tilt the bed back, and if we have stuff in it, they will sort of move along with it and all of that. That should work kind of nicely, but we'll see. We'll see what happens. I think I'm going to probably move this guy off to the side. I'm going to take some selected pieces of it that we can use. Just going to move it off here to the side so that we get a little bit of better view of the one that we're actually working on. Truck bed component. You can see I haven't actually submitted this yet. We're working exactly like we did yesterday. So we have this sine wave thing going here in the update. This is something that we can quite simply just take away. I think essentially all of that can be taken away. What? Hello. There we go. That's how you comment out things. Right, we still get the bed mesh component name, right? And in the blueprint properties, these collision shapes, I think this should be the bed collision shapes actually. Let's undo that for now because we can visualize them. Let's start by actually calling this bed collision shapes, right? Because it's specifically the collision shapes for the bed. Then we have the collision shapes for the hatches later on, and they will be a different collection, so to speak. So let's see, bed collision shapes there. Oh, collision shapes, and same thing there. And then we need to change it in the data as well. And I didn't do that. What? There we go. Bed collision shapes. And apparently I still have some. What? Slice is what it's supposed to be. And yeah, so that succeeds. Let's go here and change this to oh, come on, cancel. I didn't want it yesterday, I don't want it now either. So bed collision shapes, the bed collision shapes, and this is the most important one, the JSON name, to make sure it actually matches. Right, it's interesting that, like, let's see, change log 4192. What am I on now? Okay, I'm on 4192, but it wants to actually check for updates. It wants to update to something that requires me to buy a new license. Is that it? Or maybe upgrade my license. I thought I had access to all the 4,000, versions. Maybe not. Anyway, so that should now be good. There can still be a collision shape type, which is of course here. This is the thing that we added yesterday. So now if we go into here, let's reload the UI component definitions. Open this again. Come on, go down. Right, so now we have bed collision shapes, and then we can have hatch collision shapes also. But it doesn't actually recognize now that we actually had 3 of them, because of course we need to go in and change the name here in the data as well. So bed collision shapes. So luckily we didn't have more than this one object type which used that. So now we have the three ones back, and now if we open this up, we can see that we get these points that I added just for testing. We can move them around, and it sort of moves these spheres here. That's good. This doesn't really help us in any way, but at least we can see that the data is coming through. So let's just go ahead and remove that stuff now. Just comment that out. Bye bye. Okay, so that one we can take away. It's only used for the sine wave animation thing there. That's pretty good. So what we will probably start by doing then is to set up this graph that I spoke about. So let's do it like here. Before I had a separator here, so I have like my declarations here above. Some of these are public, some of them are not. So graph nodes. Do we want to have a root? Might want to have a root. I'm not sure, but the next one will definitely be the bed one. And then we have left hatch and right hatch, like so. And then I just have a function here to make it like you need to type int from enum and then give the thing. I just have like an IDX thing there to make it a bit shorter when you need to use like the numeric value of all of that. And for sure we're gonna need some basis math 4x3s. And we can maybe call this just physics part, like so. That doesn't need to be there either. Yeah, so Zig relatively recently added the ability to just like not have to specify the type here again. You can just do dot identity and it figures it out. Oh, okay, it actually belongs to matrix 4x3. But a lot of the code here is so old that it didn't used to support that back when I wrote it originally. Okay, so that would be the graph then. Then we need to actually have something to store the graphs in. And I'm going to probably copy over quite a few things here. So we go to, this is where we have our members scene node pointer. Oh, we don't have that. It's actually also a math thing, isn't it? I think it's found in math. Basis math scene node pointer. There we go. Graph size, yeah, graph nodes. That just makes it a bit shorter to assign it to a value like this. Then you can use it here. So we have a server-only parent node. These are kind of grouped together, I guess, in some sense. So we can keep them like that. So this will stay null on the client, but we'll create it on the server. The graph parent is probably going to be this one on the server and then the interpolated one on the client, which I mentioned. What else? Yeah, the crane arm has some like propagated values and things like that we will need to actually make this work with networking, but we'll tackle that when we get to it. First, I just want to actually get this thing to like show up properly. So let's get to that later, but let's copy those graph creation things here. Oh, and we can probably do the physics parts. So we have physics part here. I think this is going to be basically what we need. But let's do bed physics part. That would be a physics part. Physics part. There we go. And just default values. Left hatch part. It's also going to be a physics part. And then right hatch as well. But let's maybe comment those out for now, because we're not using them for anything. It's more just like a note to myself that, hey, that's how I thought I was going to make those later on. Alright. And we also don't need to necessarily do the graph parts, do the scene nodes for these yet. But we'll see, maybe I will. Okay, so now then, let's go and create that graph of ours. And of course, there's really nothing that sort of requires me to do this, work with the scene graph like this. But I think it's probably going to just make certain things easier later on, especially if we make this more complicated. Right, so some of this is going to be exactly the same. If we're on the server, we do the things we just spoke about. If we're on the client, we do the other things we just spoke about. Then we have the root, which is like, do we need this? We kind of don't necessarily need it for anything, but there might be some reasons why it makes sense to have it. Like we can essentially attach, go here to the gripper truck again. No, I haven't built this, so it's still doing its sine wave thing. But we can essentially attach the bed node to the parent right here, and then we can start rotating it. So if we have the root here, it would probably mean that the root is positioned here with no rotation, and then this bed thing is attached to it, and we rotate the bed without any sort of translation. I wonder if there's actually a reason to have that there. Maybe don't. Maybe not. Maybe let's keep it as simple as we can for now. Just take that away. So that would mean that this would actually be bed, like so. And we need to set the position. We create it as a child of the graph parent. The graph parent is basically the vehicle. The position needs to be the fixture position. So let's do something like this. Const pp props self blueprint properties question mark, and then we do bp props dot fixture position. So now we've attached the bed at the back of the car, essentially, right? And then if just for a moment we do left hatch and right hatch, actually we can probably just make the whole graph there. You just don't have to do any physics parts yet. We can do the graph. So this will be the left hatch, and we need to create it as a child of the bed, right? Now where is this gonna go? Well, it is essentially in the local space of the bed. There we go. In the local space of this object. So this position, probably like right there, like around there, in the local space of this bed, and then we have another one here on this side. Right. So that is where we want to actually, but let's not do that right now, because we don't really use that for anything anyway. We just do the left hatch, and then we do the right hatch in the same way, also connected to the bed. And then we don't need these at all. Bye bye. So this would be hatch. What's it called? The hatch hinge position in the local space of the bed. Same thing with that, right? Whoa, now I'm actually I'm offset a little bit. We don't need that either. So we create the hatch. We create the bed, and we attach the right and the left to the hatch as child nodes. Yep, that's how it's gonna work. And then I think on the destruction side, this should be pretty good. So on the server, we just deinitialize the root of the entire graph. That just essentially makes the whole thing go away. And on the client side, we don't want to destroy the root, because we would actually be sort of deleting things that are managed by the graphics engine. So you know, please don't. But what we want to do is we want to destroy the child node of the render scene, but we don't have a root anymore, so that would just be bed. The bed is essentially the root of this entire thing. You know, something like that. And that should be good. I know this might seem kind of complicated, or maybe I'm just not explaining it very well, but using a graph like this should make it much easier to just reason about where things are later on. Let's see if that builds. Actually, we're not even calling those. I keep forgetting that that Zig is is a lazily evaluated language. And so I get very confused then later on when I have like a syntax error in one of the functions that I've created like ages ago. Just because I never called it. Create graph. And then, yeah, this is where I want to destroy. Destroy graph. Something like that. Yep. It kind of looks actually like in the crane arm. So in the sort of reference for this, we're actually only creating the physics parts on the server. That might make sense for us here as well. That of course means that if you have some client-only decorative things, they won't stay on the bed if you don't have physics parts for them on the client. So I guess we might want to create them on the client as well. It might not be needed. So I don't know, maybe we'll just do it like this for the time being. Physics engine and physics scene, yeah, we need those two probably. Sooner or later anyway. Let's just copy them over here. Like that. Okay, now let's see if this actually builds. And it does look like it is working. Let's actually even run. Now we should no longer have... Oh, no! No, it does not run. What is going on? Attempt to use null value. Hey, okay. $135. Okay, yeah, so I was actually thinking if I should assert that we have this thing, and evidently I should, right? I should do this basis s assert that self blueprint properties is not null. But yeah, we don't have blueprint properties yet. What? Expected to... Oh, okay, yeah. Yeah, sorry about that, Mr. Zig. Yeah, the source argument here is just that so that we get reliable source location information from Zig. It's kind of nasty that you have to give it, but like, it is what it is. Anyway, now we get 135. And we get the function name and everything. Assert failed because that thing is, in fact, not being set yet when we get here. And so of course it is this thing here. So we might just be able to move this to on object created. Yeah, in on object created we're actually already giving the BP props. Or we're asserting that we have them. So that should work. Something like that, yeah. On the C++ side, the blueprint properties are assigned using a function. In Zig, I thought it was cool if it would just magically assign a pointer to you. But you know, I'm slowly starting to realize that these magic cool things aren't necessarily all that nice in the end. So this blueprint properties pointer thing here is assigned by the engine based on whatever stuff we put in here. So these are the blueprint properties. And this is how you can actually access them. And the order of things is that we get the create called, then this pointer is assigned, then on object is created is called. So that's why we weren't able to use it here. That's basically the reason. Okay. Right, so what is the next step then? Like one difference between the crane arm and this component is the fact that we are not actually creating this mesh for the bed ourselves. Instead we have this bed mesh component field here. And the value is bed mesh. And bed mesh is of course the normal mesh component. Interior mesh, bed mesh, here it is. Which means that this guy already has its scene node. It's already attached to a scene node. It's already moving around with the object. That's not the case in the crane arm component because we're actually just creating those crane arm visuals from code directly. That was something that I didn't necessarily want to do. I think it's better to just do it like this from data. But that means that I was kind of thinking that we would do the same thing we did in the crane arm thing, just having this bed mesh scene graph pointer here. We would attach the mesh to this, but the mesh already has one, since it's created using a mesh component like this. So what do we do? It's not really a problem, it's just something that we don't need to do. And we can even technically detach the mesh instance from this mesh component's scene node and just attach it to our own. But then this mesh component is going to be confused because it no longer has the thing attached. This is not really a problem. It's just something we have to solve somehow. There are many ways to solve it. One way is of course just to take whatever the transform for this is and rotation specifically, and apply it to that other one. That might be one way. I don't know. I guess we'll get to that when we get to it. In the meantime, let's start working on the physics side. So we're gonna have to create those collision shapes. First of all, we're gonna have to create the physics part here for the bed physics part. It will have an actor. It will have a bunch of shapes actually. That's important to realize. And it will have a bunch of shapes and one actor and also one joint. Yes. But to be able to design that stuff, we might want to actually draw the collision shapes here in the asset preview. So when we fill in things here, rather than just seeing some weird spheres here next to the thing, we don't see them anymore because I took them out. We had the spheres here. We'd actually see the collision shapes kind of like we do here for these yellow ones. That means that we would essentially need 4 boxes to represent this bed, right? We have the bottom, the sides, and then this front piece, and we all need to sort of match them. Yeah. And then the question is like, okay, do we give those in the local space of the vehicle? That is probably the most sensible one, right? Because that means that we would see them match up with these visuals here in the asset preview. But then we would need to transform them into the local space of this bed mesh or bed object, right? Technically into the local space of the scene node for the bed. That's not a problem. We can do that. Just something to keep in mind. Yeah. Hello, Poseidon. Welcome back. Welcome, welcome. Yeah, let's start by having them show up here in the preview so that we can design them. Right, and then once that works, we will start concerning ourselves with the actual correct space for the physics there. So we can this update function does run in the editors, as we've previously seen, and that means that we can draw them here. And actually, we don't need to do anything else. We can just quite simply draw them here. Get rid of that, but we don't want the fixed position. No, we don't want that. We don't want that. We don't want any of that. We do want this though. So if the position is the center of the box, so S has, oh come on, bed collision shapes, all right. Collision. I missing there. There's gonna be some other places here as well, I bet. Collision. There we go. Right, so it has a position, it has a size, and it has a rotation. Right. Rotation is not actually all that interesting right now because I don't think we will need to rotate any of them, but position and size at least. So if the position is sort of like the center of the collision box, then what we have is sort of like an AABB actually. Basis math AABB. And we can even debug draw this with transform if we want to. So we can rotate it. I don't have much time to watch you. I'm at work, but have a good day programming. You too. Thanks for checking in, nonetheless. Yeah, it's a bit early, even for me today, but this is my job today, so you get to watch me do my work for today. Righty-o. We have like a from Euler angles. And from angle axis, I don't really use Euler angles all that much, but I do have some code for rotating collision shapes. We have rotation here actually. Whoa, it's jumping around. We have rotation here. And we can rotate things. That would be probably in C++. There's sort of like a rule of thumb here that if a component starts with basis : or something else : then that's a C++ component. If it starts with something dot, VHL dot means dot, then it's a Zig component. And so if we go to physics transform component, we look at this shape description from JSON, there should be a rotation here. Right, okay, so we can construct a matrix from Euler angles XYZ. To actually have that in Zig, I don't know. Matrix 4x3. I don't. That just means that I haven't ported it over. Oh, oh god. Oh no. Okay. Yeah. Well, Euler angles basically suck. But I bet there's a more efficient way to initialize it than this. But this is probably like 10 years old code, so let's maybe not stress about it all that much. But yeah, anyway, we can get a rotation matrix from this. So I'm just thinking ahead here because we already have that rotation field there. So it would be maybe a little silly to not do anything with it, even though I don't technically need to do any rotation for this particular vehicle necessarily. Actually, the hatches might need... Yeah, the hatches might need a little bit of rotation. Bed hatch. Come on, there we go. So if the hatch looks like this, we're gonna need to use two box shapes to represent that. So I don't know, maybe we'll actually want to have rotation after all. Okay, let's just copy this guy over into Zig unceremoniously. We have like, where is it? It's before the look at functions. It's right about there, right? So what do we do here? This would be a pub fun from Euler angles XYZ self there's no self there, right? No, because it actually just sort of like constructs a new one. So there's no self. There's just a Euler angles. That would be a vec3. And then this returns a matrix 4x3. Come on, 4x3, thank you. Okay, and then we have, let's call that X is matrix 4x3 init. What? Do I not have like a rotation thing here? That's not good. Init rotation X and Y and Z. That's stupid. Yeah, I think I have like init something sort of means, you know, create a new one as well. Because init is sort of like the canonical word or the idiomatic word for almost like a constructor, like, or factory or whatever you want to call it, like a function that creates something new. It's typically called init. So I've used that, but I also have then like init from rotation, init from angle axis, init. Here we actually have those rotations. So I guess technically what we could do is we could run it through a quaternion and then convert from a quaternion to a matrix 4x3, but let's maybe not do that. If we can just stay here in this. Okay, so of that for the time being. Why is it unhappy with me here? Found invalid token. What is invalid? I have everything commented out. I don't know. What do you want from me? Let's do pub fun. Init rotation x, an angle. That's an F32, and it returns a matrix 4x3. Okay. And I don't know what it's complaining about. There shouldn't really be anything strange going on here at all. Might just be some weird thing happening. Right, so now that's just const, and that's just const, and then this is like, is there like a built-in? Yes, sine and cosine, right? And then we have basically that. Or we can do yeah, no, that's probably fine. Something like this. So that's 1 0 0. And that's 0 cosine angle, sine angle, zero, and that's minus sine angle, cosine angle, and that's 0. Just do all of them in one go, like so. Oh, come on, what are you complaining about now? Why don't you just like my, why don't you like my comments? It just does not like my comments. Okay, well, I will take them away in a second. Chill. So then we do the y. So again, we have sine and cosine. We have cosine angle 0 minus sine angle, cosine 0 minus sine, yes. Then we have 0 1 0. Then we have sine 0 and cosine. Sine 0 cosine, and then the last one is 0. Last one is always going to be 0 because we're doing rotation matrices here. So z cosine sine 0 I'm sure this is riveting content, but this is game development. And we have minus sine, cosine, and 0. Zero, zero, 1, and 0, 0, 0. Yep. Yes. Exactly. And then we can finally do this. So from Euler angles, XYZ, That would be a vector 3. Return matrix 4 by 3. Yeah, essentially already did that. And then we have x is matrix 4 by 3 init rotation x. Y something like that, right? And then x, y, z. I think that is the correct order. So what we want to do is return x, concatenate y, and then we concatenate that with z. No dot there, thank you very much. Something like that, right? Yeah, I think that is the order, but it might be the other way around. If we take z, concatenate y, and then x. So I guess we'll just have to find out and figure out. Rightio. Maybe we'll do like a small test here actually. Let's go to means app, something that just starts almost immediately, and then we do like post init. This is perfect. So let's do const matrix is basis math 4 by 3 from Euler angles, and we do vector. We're gonna have to do it the whole thing. Vector 3 init 1, 2, 3, right? Something like that. I don't suppose I have like a print thing here. I do not. So we're gonna have to probably just look at that and copy it somewhere. Oh. Build. Let's just see that we get the same results as we do for this in C++. All right, and we don't even get it optimized away. That's neat. So copy that. Copy value, right? Actually, let's copy it into beyond compare. Oh, thank you. That's neat. That's helpful. Can I copy that? Yeah, that's better. Okay. So that's the Zig version, and then we do the same in C++ somewhere. In a suitable place. Just go to trampoline app. Which is, I guess, the closest equivalent. I'm gonna have to do basis optimize off. Probably just include math 4 by 3 and maybe even math vector 3. I don't know. And then we just chug it here somewhere. So after that, for example, we do math 4 by 3 m. I think it needs to be done like this from Euler angles x, y, z. Careful with the order there. Something like that, and then just put a breakpoint there. Alright, do we get the same thing? Is it the same thing? Look at that. It's the same thing. Alright. We did good. We did good. Alright, just get rid of all of that crap. And get rid of all of that crap as well. Coolio. Okay, so now we can do something with that thing. So if we want to use an AABB to do the rendering, basically what we want to do is construct the AABB out of the size, right? See how can we create this? We can create it with the min and a max. Okay. Well, let's do half size is s dot size dot ZLS doesn't want to play nice again. It's unknown. Well, you do know what it is. It's collision shape. Multiply float 0.5. I think that is going to work. It's going to work even better if we just tell it that, hey, this is a vector 3. By the way. So then we can create AABB is basis math AABB init. And minimum would be half size. Multiply float -1. And the max would be quite simply half size. Alright. I think that is what we want. And then we can do AABB. Oh, AABB draw, debug draw with color and transform. Right. And the transform is actually we can make it variable. So transform is then matrix 4x3 from Euler angles XYZ s dot rotation, and then transform set translation would be s dot position. Right, that would work. And then let's use basis color white, why not? And then that's just transform. Something like that. This will only work if we are in the asset browser, because there we're always like the world space is essentially the same as local space, right? So how do we do that? How do we get that? I don't remember. And self context game session get client, get app. There's something called app mode. Oh, it's just in the context. I made it too complicated. Oh, it's not in that context. It's in the okay. Means app okay, what? So means we don't have means. But we need means. Const means is import means it's probably means.sig. So that way. And then go here. Means app context get app mode is app mode asset browser. There we go. We only want to run it if that is the case. I think technically this on client might be unnecessary here, but let's keep it there for now. So if we build that, what is going to be visible to us? What is going to happen? I don't know. Look at that. Look at our beautiful boxes. So now if we start rotating this, like rotate around, you know, 45. That's probably radians. This should probably be degrees, right? That makes a whole lot more sense. Yeah, we're converting from degrees. From degrees into radians, and I think we want to do that, but we probably want to do it maybe here already. So the collision shape actually contains radians. Yeah, that's a little annoying. I'll just do it like this. Rotation. Dot rotation. Oh no, actually no. I'll do it here. I'll do it before that whole append thing. So const rotation in radians is a vector 3. Like that. That gives us the rotation in radians. And then we want to, for each of these, we want to do math from radians to degrees to radians. Yes, degrees to radians. Like so. I'll just do it like that. And then 1 and 2. Okay. And then we can initialize the whole thing with that. Okay, good. Let's build that. I still have this running here, so can't actually write to it then. Okay. What? We don't see anything now. That's not good. That's not good. Why is that? Did I do something stupid with this? Let's see. Oh, size. Come on. Rotation. Rotation. Yeah, size is supposed to be just s dot size. What am I doing? I'm just messing this up. Like so. Position and size is just fine. Rotation in radians needs a little bit more special handling. Okay. Okay. There we go. I'm have the boxes back. And now if I just make something rotated 45 degrees around Y, you can see that now it is actually rotated 45 degrees around Y. Which is exactly what we need for the hatches then. Okay, cool. So the first one would be probably the bed itself. So how long do we want to make that? The position should be probably in the middle of the truck, right? And the size should be a little less than that, but we're getting closer. Let's move that upwards. It's a bit too high up. Size, let's make it like 0.3. And then start moving this down. A little more. Something like that. I think that's pretty good, but we still want to make it a little thinner. So 0.2. Yeah, and just like ever so slightly down still. Probably something like that. That's probably fine. And then we want to move it back. So let's do -1 to start with. That's 1.5. 1.7. That's roughly in the middle of the thing. And then we make it much longer. 5, 6. 6 is a bit much. 5.6 is pretty good. Want it further back. Even more. 2.0. Yeah, 2.0 is pretty good. Yeah, something like that. That's pretty good. And then we tweak the width. So 3.8, 3.5. 3.5 is closer to what we want. 3.4. Yeah, I think 3.4 is probably good. So here we can see that, okay, we have this problem here, if we want to call it a problem. So how do we solve this? Well, we can solve it in a bunch of different ways. We can make this actually be a convex hull, but that can be a little annoying maybe. I think what I actually want to do here is quite simply like shave off a piece of this. Anyway. Like we have collisions from the car already here, and I think it probably it's just a hunch that I have from doing like collisions like this. Like I don't think we lose anything, but we might just get rid of some annoying cases where things just get stuck on this. So I'm gonna do that, and then we'll see how that turns out. So that would mean making it a little shorter. A little more, maybe 5.5 is pretty good, and then moving it forward a little more. So yeah, that's good. Let's keep it like this, and then we'll see what actually happens. We have the hatches that will come and sort of follow this silhouette of the bed. That should make sure it doesn't leak or anything like that. That's good. Okay. So then we have the front. Let's use the second one. It's probably this one on the right here. As the front. We already have the width of the whole thing, so it's supposed to be that wide, and we want it to be in the center of the thing, and we want it to be 0.2 long, like that. But we want it moved further forward, not that much. And again, it would be pretty neat to have an orthographic projection here in the preview, but again, I don't have that, so what are you gonna do? That's a bit too high. That's pretty good. Yeah, I think in fact it's almost perfect. Let's move it down a little bit. Again, one of those hunches. That's a bit too much. 7.7. That's pretty nice. Yeah, it doesn't really matter if these guys are intersecting each other a little bit. They will belong to the same actor anyway, so there's really no problem in that sense. Okay, and then we want the sides. So actually want one more, first of all. And actually, let's take that away for now, so that we don't have any confusing visuals here. I'll add it when I have this one fixed, because we will be able to copy paste a lot of the stuff for the other one. So the size for this, it's actually kind of perhaps more resembling that one. But the height, yeah, the height will be just 1. And then the width is 0.2. So it's as wide as this bed is tall, right? That's kind of the idea. And then the C position should be the same as this, right? Position, like so, but we want it moved to the side, so let's make it like 2. That's a bit too much. We can move it upwards. Actually, yeah, that's size. That's not position. It should be at 1.77, same as the front. Yep, that looks good. And then we just need to move it sideways so that it fits into place. That will be probably like 1.6. That's almost exactly what we want. In fact, I think that is what we want. Yeah. Look at that. And then we can just do copy from this. The only thing we want to negate is the X position value. And there we have it. So there is our shapes for the bed. They're still in the wrong coordinate space. They're in the coordinate space of the vehicle, and they should be in the coordinate space of the bed. But we can easily fix that. That's not going to be an issue at all. Alrighty then. Alrighty then, guys, we've been doing this for an hour and a half. I think I'm gonna go make myself a cup of tea. It's tea time. And after that we will continue with this thing. We should get... We have like most of the things now. We should be able to actually add the actors and the shapes and all of that pretty easily now, I think, with this. So we should be able to like drive around with this and see things actually collide with the bed finally. That should be neat and nice. But let's throw up a quick break, visual, and I'll be back in about 10 minutes or so. Alrighty then. And back with a cup of tea. Since you said I will do the same. Yeah. Yeah, I'd really like to have a cup of coffee, but I used to drink like 5 or 6 cups of coffee per day. And in an effort to kind of rein that in a little bit, I only allow myself a single cup of coffee right now per day. Unfortunately. But it is what it is. And tea is pretty good. Alright, so now we have this stuff set up. Now we should have all the data essentially needed to be able to get the basic bed logic and setup done here. Let's again have a look at the 2-joint crane arm, how they are doing this. I say they, it's basically me 1 year ago. So create, right, we can't actually do this in create as we previously established because we don't have the blueprint properties yet. But we can basically do the same thing in on object created. Why do I do this apply steering values here? Oh, it's just to actually set up this initial thing. We will probably actually have something similar to this. But maybe not yet. Maybe not yet. But okay, let's move this again off to the side. So physics engine and physics scene, yep. Yeah, we're gonna need to set those as well. We'll start by copying those off. Those we can actually do here in create. So we can fill in things that we need here. Maybe that way. Right. So create ARM physics parts. Let's add a function called create bed physics parts. I almost feel a little silly when I say bed because I keep thinking of the thing that you actually sleep in, but as far as I know, that is what it's actually called in English. In Finnish, you would say lava. Rekkalava. It's like the bed of a truck. All right, that's that. And then what do we do here in the create ARM physics parts thing then? Well, we essentially only need to do this bone zero equivalent thing now for the actual bed itself. That is sort of like our bone zero. World matrix, parent physics actor, right? That thing is probably, yeah, it's used as the actor A for the first joint. That makes sense. ARM physics material. Yeah, what do we use? What do we use as a physics material for that? That's interesting. I have no idea. Default ignore internal collisions. This was a bit of a hack, I remember. If I remember correctly, I needed something that would like, even if you have two actors, they should sort of collide with other objects, but not collide with each other if they both have this collisions default ignore internal collisions 1. But yeah, maybe we'll just use vehicle chassis for this. That might just work. Might just work. Uh-huh. Right, it's over here. Yeah, and then we need to actually give it a mass, that's true. Many of these things are actually some things that we might want to add to the blueprint properties at some point, but one thing at a time, and yeah, then we do the joint physics stuff. So the stiffness and the force limit, those are just set to like the absolute maximum. Damping 300, we're gonna have to try that out. So that means that like this joint is not something that you can wiggle around with. It's essentially as if they are nailed to each other, the objects bolted to each other, unless you actually drive them. And then this projection stuff is completely unnecessary. We don't really support this anymore as of Physics 5. Physics 5 doesn't actually have any projection if you're using the new solver, which I can't remember the name of now. And yeah, then we add the joint. Then we do bone 1, which we don't need to do here. And then I initialize the movement limit calculator, which we don't want because the arm is considerably more complex. Actually needs to like calculate where it can move. Not so much with the bed. Okay. So let's just take almost all of that. Something like that. World matrix, parent physics, bed physics material. And yeah, I think I'll just use vehicle chassis. Seems like a good thing. Arm physics part mass. Bed mass. How much is the bed? I don't know. I don't want to make it too heavy, but it's probably has to be more than that. Let's make it 500 and see how that works. Yeah, and then we can do that. Just rename those arm, like so. And then we have the actual. Let's see if we can just copy paste this stuff. So this would be the bed itself. Right. Bed. Bed. Bed to vehicle local matrix. Bed to world matrix. Right. Shape size. Okay, we have more than one shape now to add to this thing. Bed physics material. That should be fine. So we create a bunch of shapes, and yeah, then we assign them here. That should be fine. So mass would be bed mass, and bone 0. So that would be bed to world matrix. Right. Yeah, and since the graph now takes care of where that actually is attached. Then we release here the one and only shape. We will have a bunch of them. Right, and this would be bed. Nope, not that. Bed physics part. And all of this stuff. Right. Vehicle, bed to vehicle local matrix. Boom and boom. Just take the projection away. And arm physics, we can just do like that, and we can do bed physics. And then clickety clack away. That should be good. But now we need to get this. We need to get this this shape business done. So, if we make like a let's see, const shape list, we can do std or stud bounded array of type shape physics shape pointer, and we can make that something like 8, and then we can do var shape list. We can actually do shape list like this, init 0, and that might actually want to throw, except it's not really called that, but catch unreachable, right? Local variable is then mutated. Well, I will get to it. Chill. Yeah, so we want that essentially. I can just copy that, both of those. Oh, not there. Like so. And then shape size. Yeah. And we have the size already. Shape transform. Identity. Okay. So position needs to now be orientation. Okay. Yeah, I think we have everything we need here, but we need to reorganize these things a little bit. The shape also needs to get in here. So s.size should be what we want for this, like that. Shape transform exclusive true. Yeah, that's probably fine. Position would be s.position. But of course now, like I mentioned previously, we actually want this in the space of the V. No, sorry. We want it in the space of the bed. Bed to vehicle local matrix, which means that we can do vehicle to bed local matrix is just the inverse of that. Yup. Coordinate systems, everyone. They always trip you up. And so here we actually want, see if I get this right, transform point like that. Isn't that how it actually works? I think it is. And then we can do the rotation. That would be matrix 4x3 from Euler angles XYZ s dot rotation. Rotation, come on, in bed local is rotation concatenated by the vehicle to bed local matrix, like that. And then that is the right, and then we want it to quaternion, so then we want to do from rotation matrix. Or we can probably do init from rotation matrix. There we go. Okay, so now if my math is correct, now that should be correct. It might not be, but we'll see. And then we have the shape. Set the size correctly, the physics material, the transform from there, and we get a shape. And then what we do is we do shape list append, probably like append assume capacity shape. What does this do? Asserting the capacity is already not stored. Okay, that's good. Like that, right? And then we have the shapes. So this should be, if I am now not mistaken, should be able to do shape list.slice, and that should basically fix it up. And then we can do for, after we've created it, we can do for shape list slice s.release. Kind of like that. Is that correct? I think that's correct. This is builds. So we're gathering the shapes out of the blueprint properties, creating actual shapes from them. That we can take away. Then we create a rigid body dynamic with those, the shapes, the mass, center of mass is 0, that's probably fine. Initial transform would be bed to world matrix. Yeah, so transform is actually given in the world space. Kinematic false, CCD false, shape list, we release all of the shapes. Yeah. Yeah, that's probably fine. So in the physics API, in Basis's own physics API, things are reference counted. Much like they are in PhysX actually. And that's why you need to release them. Bed physics part actor associated with game object. Yep, that's good. We actually have a game object here, so we can just do self.gameObject. And then we add the actor to the physics scene. And then we take this inverse thing, which we need to use later on when we want to drive the actual joint. With the parent physics actor, which we yes, properly get from the context. That's good. And I think this is probably correct. Bed to vehicle local matrix. Yep. That should be good. And then the bed physics actor, we attach it at its pivot point essentially, so 0 and identity right there. Right, but we probably aren't calling this yet. No. So again, let's make sure to call this before we actually verify that it builds. So if we want to, we can now do the same thing we did in the crane arm. So we just create the physics parts only on the server, and that might be enough or not, remains to be seen. And in the destroy function, we'll want to do something kind of like this. We don't have a destroy visuals at least yet, but we do have a destroy bed physics parts release. Now we might get some, yeah, now we're getting errors. Now we're getting errors. Okay, yeah, okay. That's an obvious thing. All right. Okay, well, it hasn't blown up yet. Look at that. Look at those beautiful physics shapes that we have going here. And now if we fill this with crates, yeah, we need more spring power here. But look at this. Whoa, they're kind of slidey. It's slidey. Let's turn off those. It's kind of annoying, those physics visualizations there after a while. And yeah, they sort of penetrate the side there a little bit, which just means that we have to actually make those. We have to make those sides a bit thicker, probably, from a physics perspective. It's a little bumpy. It kind of bumps. Bump. Things still fall out, but at least they just fall out the thing. It falls out through the back, where there actually isn't any collisions yet. Okay, so let's try. We should be able to just like increase the spring strength here without even shutting the game down. It's one of those things that you can modify while the game is running. So it's game, vehicle defs, gripper truck, and we have spring strength is over there, and we can probably tweak it sort of uniformly, make it 18,000. You can see it almost kind of, actually not even almost, it does sort of lift itself up a little bit better. That's good. Okay. Yeah, it's still a little slidey. I've never driven a truck of any kind in real life, but I don't know how realistic this is. Yeah, you can see that we do need a little bit thicker walls there from a physics perspective. Kind of has a tendency to sort of penetrate those walls a little bit. But luckily, with our nice data-driven setup now, it should be really easy to do that. Okay, this is already easier to drive now that we have a bit more spring strength. Spring strength. Okay, this is fun. I'm already liking this. I'm just gonna add like 2,000 more for good measure there to the springs. That's good. Let's leave that as it is for now and go here. Gripper truck. And so the sides. Actually, we can even see here that those don't quite match what they should. So it would be the last two objects here. That is probably already quite enough. Let's make that 0.55 and that 0.55 and bring it in a bit closer. Is that good? Or is that too much maybe? That might be too much. Do 2.5. 2.5. I think that that sort of thickness is good. Something like that. Let's try that, and I want to do something more interesting than what we just did. So let's go to depot. And yeah, let's create a vehicle here. Somewhere here. I'm gonna create a layer for that. Let's call it truck test. And we actually need to. Well, actually, we don't need to outload it. We can load it from a script. But we create a truck over here, a little bit off the ground. And then we also fill it with crates. Crate. Let's get like a couple of these smaller ones. Can we fit one of these larger ones here as well? Yeah, looks like we can. At least visually. Right, there's quite a lot of space there in the back of that. Now if we had the hatches, they would be nice and secure, but of course we don't, so it's gonna be chaos. As always. So we create a script here. Script. We call this truck test script. And this guy will have just a dev function, which we just call truck test. And we do load layer. And the layer is called truck test. And yeah, we can block, and then we can do on layer loaded if layer name equals truck test. Then we set single player avatar to be level objects truck test gripper truck 1. Alright. How about that? Would that be fun? Truck test. Hey! It'll be more fun when we have like sounds and particle systems and everything, but what? It's super slidey with these things in the back. Yeah, we definitely need those hatches there at least. Of course, this thing will get like the gripper in the front. That's why it's called a gripper truck. And with the gripper, it should be able to just lift things up and sort of throw them in the back of itself. Yeah, we might need even more spring strength actually. Just keeps hitting that. Keeps like compressing it fully. And that sometimes makes things sort of fly around the back a little bit. Like that. But yeah, it'll be interesting because like some of the missions in the campaign has actually, or my plans include having AIs actually drive around with things in the back of this truck, so it's gonna be interesting to see if they manage. Yeah, let's add even more of that spring strength. 35 maybe. Let's see if it can sort of manage to not continuously compress the springs fully. Yeah, they're sort of jumping a little bit. It also, of course, it has to do with things like how what is the physics term? It's not elastic, but it's like essentially elasticity. So basically we need like a little bit more elasticity perhaps in the material there. Right. Material. Physics material. Restitution. Yeah, I think that is the term I'm looking for. Restitution. I'm sure we can do some really funky things here if we start to like back up onto some higher levels. Oh, that might actually not be drivable. I have some cliffs here that I want to sort of try this out with. Yeah, it's just super slidey, this thing, when I have things in the back. But we'll see. Okay, so let's just try to back up onto that thing. I can't do that actually. The things keep falling out, which is fair enough. We don't have any hatches yet. And of course, if you just drive head first into something, then you expect the cargo to sort of slide forward inside of the vehicle, which it does. That's also nice. Like this. Boom. It's actually super slippery, even the materials there. It like glides as if it was sitting on ice or something. That's perhaps not optimal. But yeah, basically this works. Needs a lot of tweaking, but that's always the case with these vehicles. For better or worse. It's always going to be the case with these vehicles. Whoa, slidey truck. Let's just poke it back in. Poke. Oh, Jesus. No. No, my beautiful cargo. We can, of course, we can do something like this. Add one of those big ones. The second big one. How's the suspension holding up? Yeah, it's a little ridiculous, isn't it? Just like, it's just sinking. Let's give it a bit more of that spring strength. 40,000. How much does the mother vehicle actually have? Spring strength. Yeah, that's 30,000. Yeah, I'm not really approaching this from like a physically accurate perspective. I just kind of input values that make it behave how I want. Which may not be the most efficient way of doing that, but so far it has worked out kind of all right. Yeah, this is essentially like the essence of the entire game. I think this is one of the absolute sort of origin story ideas for the entire game, the entire premise. Let's have a truck in a sci-fi environment, and the cargo is like dynamic objects, and then you need to take it somewhere. This is kind of like the core of the entire game in a nutshell. Then of course there's a lot of like other things that have just come sort of into addition to that, been added to the mix. Still, this was sort of like, what is the game about? Well, it is about driving around in a sci-fi environment, and you need to be careful because your cargo is dynamic. And this thing just slides like crazy. I think I might have to move the center of mass a bit forward. It does feel like it is maybe a little too far behind. I think that actually kind of makes sense. If you're thinking about this with like an empty truck, most of the mass is going to be like here in the front where the engine is and all of that. Center of mass is a bit forward. Let's move it a bit more forward, like 1.5. That might make it less slidey. It also might not. I don't know. Maybe it didn't make it less slidey at all. But it doesn't necessarily feel any worse to drive. Ooh. It also doesn't necessarily feel any better to drive. I'm just doing like wheelies and turning on two wheels here with this, while having the car go in the back without having it fall out, I should add. Oh no. Okay, well this is fun. That's a good sign. What's next then? It's probably like the tilting of the thing. The tilting of the bed. So far we haven't really done anything particularly interesting with the whole scene graph and all of that. But shouldn't make it super tricky to actually start messing around with that. So if we have the crane arm again. Let's have a look-see here. Right, steering values is a propagated value handle for a vector tree, so that it essentially just means 3 different floats. We don't necessarily need that many. I think we might want to have maybe 2. So if the tilt amount of the whole bed is 1, and then we have the hatches opening and closing, that might be another float. We can perhaps use that float for various different things, but then at least we're sort of propagating them together as a vector 2. That might be handy. So where's this thing used? Initialize. Yep. Yeah, so pre-tick is essentially reading input, things like that. Get correction input. Okay, so it's using rotation input up and down, forward, back, and then updating the steering value, and also the movement limit calculator is doing some like correction of that stuff, and then we update the steering values. The steering values aren't actually used there, they are used here in apply steering values. Yes. Exactly. Current rotation around root. Where is that actually used? Probably in apply steering values as well. This one. Rotation around root. Right, okay. Init rotation Y. And then we just set it in the graph. Yup. Yeah, this should work basically exactly the same. So let's just get on it. So if we update the graph, that will update now the physics part. It won't actually update the visuals. We need to do that by hand. Let's figure out exactly how we want to do that. Let's start with the physics part. So there's probably some shortenings here to do. And that will make certain things just nicer. Yep. And then we'll want to have steering values, right? That's what it was called, wasn't it? Yeah. So we just copy this thing here, and we can do. That's a vec2. Oh, come on. Vec2 basis math vec2 like so, and x will be bed tilt amount. So 0 is no tilt, 1 is full tilt. And this other one would be hatch open amount. 0 is closed, 1 is fully open, something like that. Well, we'll figure out the hatches when we get to it. We'll get to them. And then I need to initialize this. So this can just be truck bed steering values. Make 2 in it. Make 2. Here we need to just de-initialize it. Yeah, and this is interesting now. So steering values are initialized with rest pose rotation. Okay, but we should just be able to do like 0 and probably 0 here as well for the hatch. And then the C component is just removed on steering values updated. That's like a callback that is fired when these things are changed. Oh, we don't destroy that yet. Yeah, we need to set that. Steering values would be a vector 2 in this case. And then yeah, we can have a function called apply steering values, which we will implement in a bit. But I think we should do that. Destroy physics parts. So for the time being, it's essentially just this, and that would be bed physics part. So remove the joint and the actor, and then release them. That's fine, and that is called properly. Yes. Okay. That's cool. Okay then, so we basically have the steering values here. We can now set it. We don't use it for anything yet. In pre-tick is probably where we will actually want to do that as well, just like in the ARM. But maybe we'll want to just do some sine wave business here. Again, just like we did previously, right? So that's what F32, because then we can just mess with this and see how it actually works. If the physics are as they should be. So in maybe tick. So let's do like if self on self context on server. Again, we do t. We can do self dot rotation plus commit tick plus equals tick delta time. And we do self. Actually, we do const t is standard. There was a sin. Yeah, there's a sin built in, but there's also a sin function. I just realized this. Well, this is confusing, but okay. Self what? Let's not concern ourselves with that right now. It might just be a Zig thing that Zig doesn't. There's some duplicate stuff there because I think the built-in was added at a later point. And then let's see, where's the pre-tick here? And it's right there. Okay. Yeah. I was trying to find something here. input handling here, and the crane arm is a little bit complicated. Steering values. Yeah. Right. Exactly. So, as a hack, we'll just do this. We'll do const remap t maybe. Is basis math remap float. We have t. We go from -1 to 1. We just want it to go from 0 to 1. Right. So yeah, we could have just like taken it by ×2 and then subtract 1, but that's the same thing essentially. And then self dot steering values set, and we have vec2 init, and here we have the remap t, and for the hatches we just set 0. So now it should essentially do the same thing as before with the sine wave, but now it does it for the physics side so far, until we have synced the visuals and the physics side. But this should make it kind of interesting to play around with physics and see if they actually do work how we expect them to. Maybe we'll do like just slow it down a little bit, right? Something like that. Half speed. Does that build first of all? Let's see. Oh, it's probably running, isn't it? It's probably running in the editor. Yes. Yes. Let's export this so we can shut the thing down. Like that. And that builds. Okay, good. So now then, we need to still use this somehow. When we will use it here in apply steering values. Yeah, and it's called actually from the creation code in the ARM as well. So from over there. And so basically, steering values is that. Rotation around root is not the correct. This would be tilt amount, right? And then to make things even more complicated, it's actually like the it was supposed to go between 32 and 0, wasn't it? And we're converting this to like so many different things now, but let's just do this. So degrees, tilt degrees, basis math remap float, tilt amount 0 1 be 0 to 32, so essentially just multiply by 32. That's fine. And then we want this tilt degrees radians. So it's not supposed to degrees, it's just tilt radians, like so. And we can do something like this. We can essentially copy all of this and move it into here. Radians, and that should be x, around x, tilt rotation, init rotation x, tilt radians, and then this is bed. Right? Does that work? I think that should work. And we shouldn't see any visual changes. We should only see... We should only see physics changes, but we don't see that either, of course. So that's not good. And why do we not do that then? Well, that's a good question. We are running this. Yep. Alright, so is the callback getting fired? It is. Okay. Oh, yeah, I think I know what the problem is. We are most likely rotating the scene node, but that doesn't mean that that it's propagated to the actor, right? We need to drive the joint. Yeah, to drive the joint. Exactly. So, if not self dot bed physics part joint is null, then this will now be if I basically take the same thing we had here. So bone 0 to vehicle would be bed to vehicle, and that would be bed. So we get the bed scene node here. Then we get the local to ancestor transform. Ancestor is the graph parent, which is the vehicle. So bed to vehicle as a matrix. Then we have a drive goal matrix. That would be bed to vehicle concatenate with bed physics part. And then set that as the drive goal. Yeah. Yeah. I think that should be it. Hey, look at that. Check out the working physics thingies. Check that out. Oh. Things fall off. Exactly how you expected. How we expect them to. Great. Oh, hey, yeah, just like you need to be a little bit careful with this when it is actually up in the air. Things are actually falling off now. That's, I mean, that's good. It's good that they are. I was of course talking about perhaps increasing the friction a little bit there, but it might be a good idea that they are kind of slippery in a sense. Yeah, that works. Okay. Okay, so how do we now sync the visuals then? That is the question. So apply steering values is fired on both client and server. We can run all of this, but then this thing is not run on the client because we don't have the bed physics part there. That is not necessarily an issue because we do have this guy. Right. So what we could do here, we could do something a little naughty. we could do something a little naughty. By essentially, we are getting the bed mesh data here, mesh component data. Mesh component data contains the scene node, the mesh, and the mesh instance. We can take this mesh instance and we can detach it from the scene node. And we can attach it to our own graph. And then when we are destroyed, we basically reattach it, right? That's a little naughty because the mesh component doesn't expect that. But it might not be a bad idea to actually do that anyway. That way we don't have to do anything. We have all the rest of the code in place already. Let's just try that. I'm just gonna write here. Let's do a couple of those and let's do hack. Detach the bed mesh from its scene node and attach our own graph. Right, and that means self bed mesh data, scene node, detach, mesh instance, self bed mesh data, mesh instance. And then we do self graph, graph nodes, bed, IDX, attach, mesh instance, self, bed mesh data, mesh instance. So we take it away from one and attach it to another one. And look at that. Now it's just all working and stuff. Look at that, isn't that beautiful? Now it falls off. Whee. It's almost completely impossible to add anything to this thing now because it just doesn't stop moving. We can probably add it when it's going down, you can add it. Ah, no. Okay. Well, that... Oh. Well, hello. Yeah, you can just add... You can add like a scout on top of this guy. Scout. Everything works. More or less. Yeah, this works fine. And it's pretty fun. So now of course is the question, like, is this a good idea to actually detach it here? It might be a completely okay thing to do, but there might also be some code somewhere which expects the mesh component to actually have that thing. And so what we could do instead of detaching it is to quite simply copy the transform. So not do that, but instead do, let's see, create graph, destroy graph. Let's probably goes in here and apply steering values. So if, let's see, if self context on client, we do something else, we do something else. And here I'm actually going to probably assert that self bed physics part joint is not null, instead of checking if it is, because it shouldn't be null on the server. Like so. And then basically we do, let's see, bed yeah, we can just do this. We can do self bed mesh data, scene node, set orientation in space, parent space, immediate update. Nah, we don't need to do it immediately. Immediate update, just like it can defer it if you do a lot of heavy calculations in a scene graph. Might sometimes be a good idea to just defer it until you really need that for something. What's going on? So it's not null. What? Where? It probably hasn't been created yet, right? Is that the thing? Is that the thing? Yeah, that is the thing. So we'll just move it after that. That should work. And there we go. So now, rather than like yoinking it from the graphics engine, which might be a little questionable, we're just asking the graphics engine to move it for us instead. That's probably better. Let's make sure this actually rotates around the axle that it's supposed to rotate around. It's a bit jittery, and that sometimes happens with this. Like you can't almost see it when you have the camera at a normal position, but you can see some jitteriness there. Might have to tweak some values to allow it to essentially settle down. It might also be that we're just continuously driving that joint now there, right? And that might actually cause it to like do funky things. Like what if we do actually like, what if we make one of those, put them upside down in the level? Truck bed work. Right, we take another one of these and just move it upside down. Rotate it upside down. Like so. Then we play this. Yeah. Just does funky things. Oh, it actually corrected itself. That's unfortunate. That probably has to do with this. Let's make the center of mass not be below the vehicle. Does it still do it? Nah, it doesn't do it anymore. Okay. Yeah, so now we can see that it actually kind of just works both ways. Isn't that beautiful? I think that's pretty beautiful. tried to drive this, but it doesn't help. Okay, that's fun. At least it's a pretty stable system, which is of course what we want. Good. Okay. Let's take the hack away. We don't need that. So with this, system, we should be able to create the hatches kind of easily, in the sense that we can just use the same graph for those. I'm thinking, is there something complicated there? There might be a little bit of complicatedness in setting up the collision shapes, right? That might be a little bit of complex stuff. Like, I don't exactly know how I want this this input thing to work. I might have to have a think about that. I was thinking, what if we just made like the hatches open and close with a sine wave as well? And then we could mess around with that some more in this stream still. That might be kind of interesting. We have some new people on the Discord. So, just like always, let's do a little bit of Discord plugging here. If you want to play the game, you can do that already. A slightly older version is available for you to play if you join the Discord. And soon, a newer version will be available to you. It may still require you to join the Discord. I haven't exactly. Well, it kind of depends on if I get the builds onto Steam or not. Or actually, I do. I already have a build on Steam for just my own testing. But if I have a build that I deem good enough on Steam, then I'll put it there. Might be the next one, or it might be the one after that. But in the meantime, if you want to play, join the Discord and you can find the links there. I'll just ask for help and someone will show you. And you can find the invite link in the description below. Right, so let's maybe just keep going a bit further. We haven't we've been at this for 3 hours soon, in 5 minutes or so. But let's keep going a little bit further and just do these hatches here. I'm gonna have to do them anyway, and might as well do them now in one go, now that I have this thing in somewhat fresh memory. But I'm gonna go get a little bit of water. I'm talking so much that my throat is kind of dry. So back in a little bit. Alrighty then. So I'm gonna have to export this hatch. I'm probably gonna have to export like 2 of them, a mirrored one as well. I can of course sort of scale it -1 on the x-axis. That might work, but in the end I'm gonna want to have 2 different meshes for them anyway, so I might just export them right now as 2 different meshes and sort of get it over with. I wonder, this pivot point is up here. Is that like a good thing? Maybe it is. I wonder how I determined that would be a good pivot point for this. Sort of like between the top and this upper, whatever the hell fixture this is. But yeah, let's keep it like that for now at least. So this would be bed hatch left. So let's duplicate this guy, and now we can actually, let's see, location minus, move it over there. Then we take that and we scale x -1. Do we need to do it here actually? For it to, yeah, something like that. And then probably, no, that looks good. We just need to apply the scale for that guy. So scale. Oh, now it changed. Okay, so now we need to flip normals, and there we go. Yeah, this they seem to sit kind of nicely and neatly here. So you can rotate this sort of like this. Blip. Something like that. I think like in real life they tend to kind of turn up, not sideways. But I figured might be best to have them rotate like this, because we don't really know if we have any like really large, like the large crate needs to sort of be dumpable like this. What's up with that guy? That's not a, that's some weird, is this the strange geometry date thing again? No, it's not. What's going on with that guy? It's that's not a planar face. No, it's a planar face. What in the world? This guy kind of looks planar. No, it doesn't. It doesn't actually. What is this? What is this madness? What is this madness? Yep, it's some kind of madness. I don't know what I was thinking with this. Let's just delete that for the time being and fix it here, and then we can duplicate this again. What was I thinking with this one? Yeah, I think this is just simply supposed to kind of go all the way down. That's probably the best solution. Like that. Yeah, I think that is probably what I meant. Oh, that might be fine. Right, we don't have the 3D printing extension thingy anymore in Blender. Internet access is required, yeah, well, that's fine. 3D print toolbox, yeah, I think that is the thing that we want. 3D print, there we go. Check all. Overhang faces, that's fine. Okay, so that's better. That is better. Okay. So now we can do left bed hatch. And then duplicate. Negate that one. Negate that one. And apply the scale. Flip the normals. And there we go. That looks better. So now if we rotate that around Z, rotate that around Z, and we rotate that around X. So now we should have no wonky faces or anything going. Nope, that looks good. Okay, good. So, the way we need to export this now then is we need to move these guys to the origin when exporting. I am a little bit confused about this pivot point though. Why would it not be like in the middle of the thing? Might be a good reason for that, but I can't really think of any. So maybe what we'll actually just do is that needs to be renamed, by the way. Right. Maybe what I'll do is hide that and hide that. Yeah, we have these faces here. That's probably fine. So let's take the left one and object set origin to 3D cursor. And then we do view 3D cursor and negate that one. Move the cursor there. And then we do the same thing for this one. Origin to 3D cursor. So it's like in the middle of that. I think that probably makes more sense in the grand scheme of things. Or something. And then what we need to do is just zero that out. And we probably actually need to do a what's it called? It's called Smart UV project. And we export this as gripper truck left hatch. Left bed hatch, maybe. Yeah, I need to do the UV project before moving it. Same thing with this. Zero that out and do right bed hatch. Like so. How about that? I think that should be it. That should be everything we need to do in Blender. So now then we need to Yeah, we need to add those, essentially the same data we have for the bed here. So we have a fixture position, the mesh component, and then the collision shapes. So we need to add all three of them to all three of them for the hatches, right? So left hatch fixture position, left hatch mesh component, and so on. That shouldn't be too big of a deal. We have this open here. So essentially just take that, move them away a bit. So left hatch. Where the left bed hatch is fastened. And yeah, this is left hatch. So left hatch mesh component name. And left hatch collision shapes. Yeah, and we can use the same type of collision shape for that as well. That's fine. Yep. And then same thing for the right. So that would be right. Something like that. And if we do this, I think we should have all the data we need to set up that. And then we do the same thing we did with the actual bed, in the sense that we make it draw those hatch collisions, right? Reload component, UI definitions, then gripper truck. We'll go all the way to the bottom. And there we go. That would be that. And for these we actually need the rotations, so I guess paid off to actually add those in the end. But we need the meshes, right? We can add the meshes already. Except the game will actually complain that we have some unknown fields there. So let's quickly get those in. So fixture position, bed mesh component, bed collision shapes. So let's do left hatch. And that would be right hatch. Something like that. And I'm kind of bummed that this is not called, you know, bed fixture position now. So let's make it call that bed fixture position. We need to fix it in a few places. So that needs to be bed fixture position. Just shut that down for the time being, and that would be bed fixture position. Same thing there, and there, and there. Good, good. And then this would be left hatch and right hatch. Add the bed there as well. Something like that. All right. Needs to be string. There we go. And this is perhaps a little silly to have like 16. It's just add like 4. I think that's probably fine. So this would be like, you know, bed. There's a little bit of repetition here. Maybe this could be actually, you know, extracted into its own struct type, and then you would just have a list of those structs. But it's fine. It's fine. It's fine, you guys. No one cares. Left hatch. Fixture position. Left hatch mesh component name. And that would be left hatch collision shapes. Yeah, there's a little bit of repetition here. No one cares. Absolutely no one cares. It can be made nicer if it annoys someone later on. Like so, right? And then we go to update. And we do left hatch collision shapes. And we do right hatch collision shapes. It would be pretty nice to have this separated out though. I can't say that it's very nice to have it like this. Can't be bothered. Really? Really? What? Left hatch fixture position. Left hatch fixture position. Yep, it's right there. Is this the thing that doesn't exist? It does. So what are you complaining about? No field name. Left hatch fixed to position in props, so it's this guy. But it's right there. Visual Studio Code is even highlighting it for us. What are you saying? What are you saying? Oh, there's the issue. Small f. That's not good. Be better. Alright, so that works. Good. Now we should even see those. Isn't that fun? So if we now go into here, should be able to do a whole lot of things here. All of a sudden, things should start falling into place. Nope, missing field. Same thing here. Oh, we need to reload that. There we go. It's still not liking it. Did we actually? Let's see. Let's do a quick diff here. Rip. Bed fixture position, bed mesh component name. Yeah, it has none of those. That's fine. We've just added them. Should we just save that? Is that the issue? That it wants to have them all. Yep, at least now we have them all. Still have the small f though. Ugh. Come on. Come on. Right hand fixture with a large F. Left hatch fixture with a large F. That should now be all good. Reload the things. Thank you very much. And now then. Diff it for me, please. There we go. Okay. Now we have the large Fs. Where are we at today then? Well, we basically continued from where we left off yesterday. So welcome, welcome. And we already have this this bed here moving up and down. I can give you a quick little look at what I just made working. So it's still driven by a sine wave. Haven't exactly decided how I want this thing to be controlled, but you can see that it actually does affect physics. Yay! And it's even making things fall out of it. Bloops. So this is the hottest new thing in town. Need to decide how I want the inputs to work. If you're supposed to be able to control the angle directly, or if you just like press a key and then it kind of tilts, and then you press a key again and it goes back. But it seems to be working pretty nicely. So what I was thinking I would still do today is add those hatches in there. And with those we can do a whole lot of things. So we need to give it the fixture positions, which I can convert from Blender to Basis in some sort of half-assed way here. So let's see. X needs to just be flipped, essentially. X is just flipped. Actually, I'm gonna copy this into just the text for file here. That's X, and then we have Y is Z. Yeah, Y is Z. So that's Y, and then Z is Y flipped. Right. No, Y is not. No, sorry. Yes, it is. It's Z flipped. That also needs to be flipped. So that's the left hand side, left hatch side. And then the right hatch side is the one without the minus in front. We have physx ed. Okay. Do you mean this? Is this physx ed? Or are you telling me we already have something that would make this easier? Either way is fine. By the way, okay, so we have bed mesh here. Let's add the hatches be below that probably. So just do component, mesh component. Okay. Hatch. So gripper tuck left bed hatch. Dark gray maybe. Let's move this up. This is a bit cumbersome when you are actually have a lot of components. Means vehicle. Interior mesh. Bed mesh. There we go. So left hatch mesh. All right. And let's see. Does this like crash and burn now? It does not. Right. So now we need to just put in this position there as well. Right. And we have it there in place. Look at that. Beautiful. I was joking about the boxes falling out of the truck. Ah, I see. Yeah, there's none. The reason I didn't get that was that there's not a whole lot of like editing. Well, you can add things and remove things. That's about it. But yeah, it's pretty fun already actually. Just messing with that. So that's cool. Yeah, I want to make these hatches just slightly different colors. So let's maybe use the slightly lighter gray for the hatches there or something. Just to sort of kind of differentiate between one and the other. And here's a life hack. These guys are just JSON files. Here's a life hack for you. And they're just the JSON files, so you can just go in here and modify these from JSON, and it should just work. So let's do right and right and like that. Now we should have the other hatch there as well. There we go. Yeah, sometimes like loading these blueprints is a bit slow. It's 100% just building this WinForms user interface here, because that is so slow. It's super annoying, actually. Yeah, sometimes it can take a little while for it to populate. Okay, so we have those. And now we need to lay out these collision boxes for these things as well. Yeah. And we can probably use some of these sizes that we have here. So like, let's see, the sides, this is one side. So we can definitely use like the height of it, at least. Let's see, let's something like that. Let's put that as the size there. It will probably, yeah, it will appear there in the middle. That's fine. Let's copy that actually and move it there, and then we can rotate around Y like, let's say 45 degrees. And actually we want the minus 45 degrees if we want to sort of emulate this part here. And then we can start moving this back 5. No. Oh, I did 51 actually. Right, I'm missing a minus sign there. Yeah, editing this by just inputting numbers is okay, but it's not particularly enjoyable. But it's just so much work making it so that you can actually like drag these things. I haven't bothered. I just simply haven't bothered myself with that. At least not yet. So the hatches are perhaps visually a bit thinner than the rest of the bed. Especially here in the back. I think they are a little bit thinner than the rest of the bed. I don't think we will want to make them thinner than the rest of the bed physics-wise, though. Especially since we had a little bit of stuff poking through those until we made them thicker, and you know, players tend to look at this vehicle from around here. So if you have stuff like poking through there, that's gonna look really bad. So let's not do that. Let's keep it just as thick as always. And that needs to be like vastly more short and shorter. Something like that, maybe. Yeah, even shorter than that, I think. Yeah, I think that will probably do. I was gonna ask, have you played Roadcraft yet? Remember you mentioned it a few months ago when they had a demo up. I have not played it. And I don't think I've mentioned it. I might have mentioned something similar. But I haven't played it, and I actually just realized a few days ago that game is a thing. You can sort of immediately see, just by looking at it, that okay, this is clearly like a Mud Runner Spin Tires descendant, just from the way they do the, well, visuals essentially. And I looked at that. I think it was. Oh, that's not what I was meant to do. I looked at that in Steam, I think, or something, and I saw that. Oh, that's clearly what's going on here, and it was, and it looks cool. But no, I haven't played it. I have been thinking about maybe playing it as a sort of a research thing for this. I haven't played. I also haven't played the what was it called? There was an earlier game which was also an expedition, or sort of a descendant from Spin Tires / Mud Runners, more sort of like an expedition thing, which also looked pretty cool, which I also haven't played. So yeah, there's some holes in my education there, right? But yeah, it looks good. Have you played it? Is it worth picking up, maybe? Alright, something like this, maybe. I don't know how exact we want to be with this. Maybe I'll want to be a little more than that. I think the inside is pretty okay right now. I want to move this a bit backwards. A little bit backwards. So let's do that, actually. That's too much. That's probably good. And yeah, this is a little thinner, like I said. I don't particularly like that it's a bit thinner than the rest of it. But let's at least keep it like that. The same thickness physics-wise. And that way we don't have any geometry poking through there, which might be annoying. Right, so yeah, I think even a little bit less, something like that. Yeah, that looks good. That we can live with. Maybe it was someone else in the chat then. Yeah, I do think so. I do think so, because I really just the other day I realized that oh that looks like a Saber interactive thing. Looking forward to Over the Hill from Fun Select, the makes of Art Rally. Art of Rally is really excellent. I played a lot of that. It's too difficult for me in the end. It's too difficult for me in the end, but yeah, I played a ton of that. And yeah, the art style that they're using is kind of, you can clearly see it's made by the same person or people, I don't know. So yeah, that's probably gonna be fine. Let's see, I need to get the left hatch mesh and then right hatch mesh, like so. And that would be that, and then we need to just essentially copy paste those things. So maybe we'll do the same life hackety hack once more. Just do this, whoop, and then I'll just reload this guy. And of course they're gonna sit on top of each other now, but we will fix that. So it's that, right? And then the rotation is the other way. Yeah. I mean, you can do certain things kind of neatly with this editor. It's a little crummy and crappy and decidedly homemade. Just the fact that you can like copy paste those and then just tweak some things. It's not that bad. Okay, I think we have everything we need now for this. So, with a little bit of luck, this should work out. Let's shut that down. Right, not yet got too large a backlog at the moment, still on Doom the Dark Ages. Right. Yeah, I haven't. I got a bundle the other day from Steam with 2 games that I've been meaning to play. 2 very different games that I've been meaning to play. One is The Invincible, which is based on a sci-fi book, a Polish author, which is it's essentially a walking simulator, but it's pretty cool. It's not very long, which suits me just fine. Don't really have time for that many games currently. The other one was Pacific Drive, which I'm convinced is an excellent game, and on paper it would be kind of my My perfect game. For some reason I can't really get into it. It's strange. Like it's I don't know, it's too fiddly for me somehow. I'm saying that fully aware that my game is very fiddly as well, but like just like there's too much UI in it somehow. And the UI is not very intuitive or something. I don't know. I don't really want to hate on it because it's clearly a very good game and it's put together with a lot of love and all of that, but I don't know, it doesn't really gel with me. Okay, so next thing then is to actually create these physics parts. So now if we run this, let's see. Now if we run this, we should have these hatches here, but they're not actually getting moved around with the bed. All right, and we should be able to do the visual part actually very simply, unless I'm forgetting something. But if we look at the create graph thing here, so left hatch and right hatch, and here we have BP props. I had these comments here. Hatch hinge position the local space of the bed, but of course we now have them in the local space of the car. Right, these things are in the local space of the car, so we can't use those directly. We need to transform them into the local space of the bed, and we do that. Parent, so world matrix, blah, 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 bed to vehicle, vehicle to bed. Right. It's basically this. We need this. Create graph. And we can do that here. Let's see. We need to set it immediately. Set position uses set position in space in the parent space with immediate update false. We can't have that because we're gonna get it here right after that. So we instead want to use set position in space. Let's copy all of that. Copy that part and do set position in space. BP props bed fixture position. Space is dot parent. Immediate update is true. And now we should be able to use this. Yeah, exactly. And now with this we should be able to do that would be transform point and then BP props left hatch fixture position. Yeah. Yes, that should be good. And then same thing here with not direction, transform point, BP props right hatch fixture position. Something like that. So now the graph should be essentially updating correctly. And now what we can do is we can get the mesh data similarly to how we do it for the bed. So left hatch mesh data basis components mesh component data. Right, and then we do the same thing here. Left hatch self game object get and assert pp props left hatch component name right hatch self game object pp props right hatch component name and str. Right, so that, and now what in the world are we gonna do? So basically I wonder if, like, after all, you can set a parent component to be another one. So if we have the left hatch mesh here and we have the bed mesh here, we can actually set bed mesh to be the parent component of this. I wonder if this is actually what we kind of want to do. I think it is. And now it's going to be incorrect. That's completely fine. Because what we actually want here is to set this position in the space of the bed. Right? That makes sense. So like the origin used to be here and we moved it here, and that means that this thing is moved over there. But I think this is actually correct because we want the hatches to be nested under the bed. And when the bed tilts, then the hatches would tilt as well. All of that. And that way we can then just rotate, just like we rotate the bed just with a single, around a single axis. We also rotate the scene nodes around a single axis. Yeah, I think that is what we want. So how do we now then get this to work? Do we do this? Yes, we do that actually. And that means that we now get this kind of location. No, that's not right. Yeah, sorry, I've been sort of neglecting the chat a little bit here. I'll get right back to it in a second. So let's do this again. So minus that. Y is Z actually. So we'll take that first. That would be Y, and then minus Z is minus Y. Again with the conversions. So we said put that in. No, that's not at all what we want. Right, I mentioned previously that I don't really do a whole lot of transforming, right? Or parenting in Blender, and this is what I mean. I don't really know how to do this even, because like this guy is parented under the bed. The bed is now sitting at world origin, and this guy's position actually didn't change, which I guess kind of makes sense in a way. But it is for sure not that. However, if we move the 3D cursor to selected, it's sitting on top of it, this actually looks much more like what we need. So that is the position that I'm actually after here. So let's do minus that, and then Y is going to be that, and then C is going to be minus Y. So minus. I think that is actually what we want here. and it is. It's just that we need it on the other side. There we go, boom. There we go. Right. So now, even without us actually poking at this at all, if we now run the game, I'm just going to shut that down. If we now run the game, the hatches should actually rotate along with the bed, which is good. So mesh components also support a sort of transform hierarchy in this way. Right, so let's see. I like fiddly driving games. Oh well, you're in for a treat when Traction Point launches them. I've been enjoying the Slaverian Trucker lately. Oh, what is that? Let's do a quick Google thing. Slaverian Trucker. Oh, okay. Yeah. Okay. Interesting. You might want to check out My Summer Car if you like fiddly car games. Made by a fellow Finn. This has you messing around with parts of the car and you know, drinking beer and going to the sauna and all of that. Of course, since it's a Finnish game, but yeah. And yeah, trunk full of beer, obviously. Pacific Drive's UI is very stylish, but a bit confusing. I was bounced off it after a couple of hours, not sure why. Might have been the kind of game I would enjoy more when I was younger. Yeah, I don't know. It might have been, yeah. It might have been. It's something with the tone as well. Can't quite put my finger on it. I would never have really thought that it wouldn't have been for me, but after a while I was just like, these people were just like spouting some exposition at me, and I don't really care. And being sort of generally unpleasant. I don't know, maybe I'm too harsh on it. But like on paper, it's also sort of like my oh hey, hey, yeah, we've seen bugs like this before. If you drive away, then those things disappear. And why is that? Well, that is because we have a dynamic flag setting correctly. So if we draw the mesh BVH here, you can see those things are like, there's some mysterious things there. I wonder if they would actually match the transform of those, or the original transform of those things. Actually, the car was sort of sitting slightly in the air, and then it sort of fell down. What would that be? Well, that is like if those go off screen, then that just don't draw, because the static meshes in the game get added to a BVH, and so we just need to mark those as being dynamic. There we go. It's a bit of a gotcha. Escape from Tarkov is the strongest. I would have loved this 5 to 10 years ago I've ever had in a game. Yeah, I have some of those as well. Exactly the feeling that like, oh yeah, I would have like really liked this, but now I can't be bothered. In a way, and I kind of hate to say this as well, but in a way, Tempest Rising was a little bit of that as well for me. It's not a bad game. It's in fact it's a pretty good RTS. But I kind of just like I can't quite be bothered. I'd rather just play like 2D RTSs. Tend to see a bit more of the battlefield, and I don't know. It's probably just like half of it is nostalgia. But like, I still haven't finished the what is the Brotherhood of Nod equivalent of that game? I don't even remember anymore. Like, I haven't finished their campaign. I should. But it is like, for me, that's one of the most I would have loved this game 5 to 10 years ago. I've had in a big long while. Big fan of my summer car. Can't wait for my winter car. Oh, I didn't know there was something like that coming. Sounds like a pretty logical follow-up. All right, I'm getting a little bit. My brain is getting a bit fried. Been doing this for almost 4 hours now, but let's at least finish these hatches here. We don't have like a whole lot of stuff to do, but we need to create those. We need to create those physics parts. And there's now one important thing to remember here, and that is the fact that we actually changed these positions. Right hatch fixture position and left hatch fixture position. It's a mouthful to say. They are now in, like, already in the bed. Actually, it's these guys here. Let's see, bed mesh. This one, mesh position. We're giving them there in the bed coordinate space. So let's just do the same thing here as well, and perhaps even reflect it here in the in this. Let's see, truck bed component. So left hatch fixture position. The position in local space of the vehicle. This should be in local space of the bed, where the left hatch is fastened. Something like that, right? And that means that we can take one of those matrix multiplications, those transforms from over here. We can just take those away. Right, like that. We're already in the right space. I was speaking to CNC3, so it was an easy win there. Yeah, see, I wasn't. I have played a little bit of CNC3. I think I own like 2 copies of it, like, you know, as you do, because you get it as part of some bundles and whatever. And then you gotta get it as a part of another bundle and whatever. But that was just like, it was so unlike the Westwood era games that I was just like, what is this? That doesn't mean I don't like 3D RTSs. World and Conflict is one of the best RTSs, I feel like, ever. The Ground Control, we made by the same company, actually, was also really good. Especially Ground Control 2. Like those a lot. I like Homeworld 1 and 2 really a lot. Homeworld 3 was really not very good. And so on and so on. So I kind of like 3D RTSs, but for some reason, like some of these like classic RTS games that have just been brought into 3D, I just like, nah. I did play Red Alert 3, didn't really like it a whole much either. But then like Tiberium Sun and Red Alert 2 are just like epic. And even Dune 2000 is just like awesome. So I don't know. Warcraft 3 was kind of okay. Warcraft 2 is like the best game ever. I don't know. It's a bit annoying, honestly, to like look forward to a game and then you get it and you're like, yeah, it's alright. City 3 was Westwood still, I think. It wasn't Westwood, it was EA Pacific, but it was made up of mostly Westwood people, right? Am I talking out of my rear? I don't think I am. So Command & Conquer 3 Tiberian Wars. I think this was EA. Yeah, not EA Pacific. EA Los Angeles. But yeah, Westwood was not a thing anymore when this came out. But EA Los Angeles was made up of at least partly of Westwood people. And Westwood's last game, as far as at least Westwood's last RTS was Emperor. Right. Don't we have a list of games here? List of Westwood Studio games. There we go. Yeah, so Emperor Battle for Dune was an okay game. Then some, I don't know what that is. I don't even know what that is. Command & Conquer Renegade, which of course wasn't an RTS. And then Earth and Beyond also wasn't an RTS. It's an MMO. So their last RTS was Emperor, which is not a bad game. But I still prefer Dune 2000. Okay. Let's try to focus here for a bit. So bed physics parts. The bed itself is here, and then we have the left hatch. Right. I think we can actually probably move this guy into here. And then we copy all of this. And we do the left hatch. And the hatch can be like not as heavy. Bed to vehicle local matrix. Now I'm going to need to actually look at the two joint crane arm thing again. So physics parts. Bone 0 to vehicle local matrix. Bone 1 to vehicle local matrix. Yes, okay. So we always want to go from the current part to the vehicle in this case. So let's call this just like hatch to vehicle local matrix. And this would be left hatch. Vehicle to hatch. And then hatch to world. All right. We have the shape list. That's fine. So this would be left hatch collision shapes. Vehicle to bed. So that would be hatch to vehicle to hatch. Local matrix. Rotation in bed local. Rotation in hatch local. Vehicle to hatch. And then that's the same as previously. Hatch to world. We need to create it. Create it in the world space, like so. Bed physics part is not what we want. We want left hatch, that what it's called? Or do we actually not have left hatch part? Is what it's called. Okay, there we go. So it's just called left hatch part. And that these all need to be left hatch parts. And I should really extract this into a function. Blah blah blah. Are you having any issues with the stream dropping out every few seconds? Oh, that's not good. That's not good. Kind of seems that I can't catch a break with these internet issues recently. Yeah, I'm doing a speed test here, which I don't know how good of an idea that is during a stream, but I think there might be something funky still with the connection here on my side. I don't have any problems locally. It's an internet connectivity issue. That's not great. Thank you for reporting, though. I'm gonna have to kind of track this a little bit and see what I can do about it. Like my downstream is pretty good these days. Like, well, not necessarily good on a purely objective scale, but on my scale it's like 400. But the upstream is still kind of limited, and it tends to work pretty well when it gets to around 50. But yeah, it's a bit annoying. I apologize for that. Deepest Darkest Finland is eating all the packets. Yeah. Yeah. That tends to be how it is around here. Let's hope it is only a thing, like a temporary thing now happening with my operator or something like that. Because at least sort of just looking at the numbers, it should be a lot better than it used to be previously. But I might have to twiddle and tweak with my OBS settings a little bit, right? To get it to work better. But thanks for notifying me. I'm gonna have to look into that. I'm sure there's some OBS things that I can tweak if the upstream is indeed continuously bad. Righty-o. Okay, so the left hatch. I wonder if this is now everything we need. Hatch to vehicle, hatch to world, vehicle to hatch. Then we iterate over all of those. We create the left hatch part actor. And we add it there. We can try this and see how it works. All right, we can already see something being a little. Oh, okay. What? That's not good. So we can clearly see that, okay, yeah, it is adding those things there. Oh, I know what I think I know what this is. It is added to the base of the vehicle. That's not where it's supposed to go. So the joint is supposed to go to self.bed physics part actor. The irony that the stream was more stable on the older worse connection. Yeah, the quality was a lot worse as well on that though, right? But when the stream was working, the quality was a lot worse as well. Right, so this is now this is not good, and we have the same issue again. I am using now it's attached to the right. Now it's attached to the right object, but we're using the wrong. Let me just try to figure this out. We're using the wrong coordinate space. We should be in the vehicle space, and now we're in the bed space. Good chance it's a YouTube problem. Okay. I noticed the issue with many streamers from various countries and continents. Yeah, it might be. I mean, I guess it might be both. It's just that I've had some really nasty surprises with my operator lately. In the beginning of the stream, I told a little bit of a story. I guess I can rehash it here for you if you didn't hear it. So yesterday I had an issue with like the stream worked fine, and then at some point it just started getting worse, and then it just completely died on me, and I had to switch to the other so-called older worse connection, which I still have. It's a separate thing. Quickly switched there, and we were able to continue the stream, but I had to quit pretty soon after that, and so I just went away from home. Essentially didn't really follow up on the thing. When I came back, I couldn't get a signal at all. Like it just didn't work. The connection didn't work at all. But it was late enough so that I couldn't call the operator and go like, hey, what's going on? So I called them this morning, and I was like, hey, the connection is not working at all. I had this for a couple of weeks, and it's worked pretty well, but now it's completely dead. And someone on their side had switched out the SIM card number like on their end. So we were just like diagnosing it this morning, and I was listing all of the things. And then they were like, okay, so let's look at the what's the number of the SIM card. And I had never even seen the SIM card because it came sort of pre-installed in the thing when I installed it a couple of weeks ago. So I was like, I don't know, let's look. And someone on their side had actually just switched, probably as a mistake. I'm hoping it's a mistake. I switched the SIM card number of my subscription to another one, and I was like, what? What is going on? And that explained why it didn't work. Nothing came through. I didn't get a signal, nothing. But yeah, it just shows that I've had some like weird things happen lately with my internet connection. Anyway, right. So, I think let's try to figure this out. So we're not setting actually the drive goalposts of not setting the drive goalposts of the hatch yet, so it can't be in here. It needs to be in here. And we're calculating this somehow incorrectly because we are we are actually we're attaching this to the bed. Vehicle to hatch local. So this transform should be in local space. I think this might be the problem. Right, that's already in the bed local, isn't it? Oh, are we seeing the same thing again? Okay, now it's actually like the other way around. Yeah, that's why it's it's actually lifting the vehicle. Yeah, okay. So that's not the right. It goes the other way actually. Vehicle to hatch local. Man, I don't have the energy for this math currently. I managed it for the bed, but I'm just like, ugh. So this should be fine because we're getting the local to ancestor, and this is the same for both the bed and the hatches. So hatch to vehicle should be fine. That means that vehicle to hatch should also be fine because it's just the inverse. And then we have hatch to world, which is hatch to vehicle plus world. So that should also be all of those are fine. And then we have that, and that's completely fine. We have rotation, and rotation in hatch local. Rotation actually seems to be mostly good, but it's probably this position that's just wrong. So this position here, as we just established, this is the position in local space of the bed. Right? Yeah. And here, what are we doing here? We're doing vehicle to bed local matrix. Yeah, that's actually probably okay. That's probably actually correct. It's like the stream as a memory leak. It gets worse over time. Yeah, it's Friday night and I'm just tired. My best friend, can you prepare group join Discord page? Your YouTube channel. I want to join you. If you want to join the Discord, you can find a link to the Discord in the description below. So there is already a Discord. Feel free to join. You can also find an earlier build of the game there. Randomly changing SIM number in your account. It is very sus. It is very sus. And it's like one of the large operators in Finland has been around. I've been like their customer since like the 90s or something. So it's not like a random small thing. Yeah, I was a bit angry at them. Let's just say, hatch the world matrix. Yeah, there's something with this guy, this position, and this transform that don't match. If that makes sense. And I'm just trying to figure out what it is here. So we're giving it actually in embed local matrix. Yeah, we're giving it embed. Bed coordinates here. And so we want to give this in hatch coordinates. And we are, but this is okay. This is not. This should be bed to hatch. Actually. Yes, this should be bed to hatch. Hatch to vehicle. So we need to do another one. We need to do hatch to bed. This is the problem. And get local to parent transform. Yep, this is the issue. And then we need to do another inverse for this. So that would be we can actually do them here, right? Group those guys together. So so this would be bed to hatch local matrix. Hatch to bed local matrix inverse. Right? That's that, and that's that. Yep, okay, that's good. And then that needs to go there, and that needs to go there. Rotation in hatch local, and then we can do position in hatch local. Those kind of go together as well. Right, like that.